Today we'll be talking about dimension in physics. Dimension. Dimension in physics. What if a question like, let's say, find the dimensions of, let's say, A, find the dimension of velocity, B, find the dimension of area, and C, find the dimension of force, etc. But I want to tell you something very important about this topic. Before you solve anything concerning dimension, you should be aware of fundamental quantities. And when we talk about quantities, we are talking about those things that can be measured. For example, we have under the fundamental quantities, we have mass, we have length, we have time, temperature, and other ones. And we also have the derived quantities. All these ones you're seeing here, they are derived quantities. Now, when you're asked to find dimension, it simply means those physical property of those physical quantity that can be used to describe other quantities, that can be used to express quantities like these derived quantities here. Example, the velocity, area, and the force. Now, remember, for you to solve anything concerning dimension, we have three fundamental quantities to use and solve any problem. And they are the mass, the length, and the time. How are you going to use them? We take the first letter from each of these words. Under mass, we have letter M. Under length, we have the letter L. And under time, we have letter T. So it now becomes MLT. So we are going to use these three fundamental quantities to describe the dimension or to express the dimension of velocity and the rest of them. So let's start. First of all, we say velocity. Normally, velocity can be defined as displacement over time. That is, displacement over time. This symbol represents the displacement. And now when we talk about displacement, it's just like saying distance covered by a body in a specific direction. A body covered or a distance covered by a body from north to east, that is displacement. And that simply represents the length we have here. So from here, the dimension of length here or displacement here is L, and that of time remains capital letter T. So at this point, the dimension of velocity is L over T. But most of the time, we advise students not to express it in fraction. Instead, change it to be in this form. Bring down your L. Don't be afraid. It's very simple. Bring down your L here. Then this division sign should change to minus. So bring down up your T here too. This division sign should change to minus 1. That is under indices. So if you check, T raised to the power of minus 1 means 1 all over T. Then multiply by L. It means L over T. That's done. So the dimension of velocity is LT raised to the power of minus 1. And the second one is area. Area can be defined as length times breadth. And these two quantities you're seeing here, length and breadth, they are the same. But it's just that the expression or the way they appear is different. The length and the breadth is talking about length, which is from here. So at this point, the dimension of area is length times length. And that is equal to L raised to the power of 2. Why is it L raised to the power of 2? Because L is raised to the power of 1. And under the law of indices, it states that when the base are the same, take one of the base and add up the pair. That becomes the final answer. And let's check the last one, which is the last one now is force. We said that force is equal to mass times acceleration. And we know that the dimension of mass here remains letter M. But what is the dimension of acceleration? Good. The dimension of acceleration, let's see. Acceleration is talking about change in velocity all over time. And the dimension, remember, velocity here is L t raised to the power of minus 1. Then time, the dimension of time is capital letter T. So breaking this down as we apply here, we have L t raised to the power of minus 2. Because this invisible one, 1 minus 1 is this. So from here we have here acceleration. We have acceleration to be L t raised to the power of minus 2. So therefore, force is now equal to mass times length times time raised to the power of minus 2. So this is the simplest way and a better way to solve for dimension of any quantity. Thank you, Lord. We meet again in the next class.